Yay. For me. I'm going to end up with my link. Hello.
Hi, Rebecca. How are you?
Doing well, thank you. How are you?
Good.
I don't know why it has my name.
I don't know why either. I actually changed it in the settings, and because it popped up as Rebecca. Let's see if I can. And I put my name in there, and then it wouldn't allow. Oh, here we go. Maybe I can rename it here.
Okay.
Do this again.
Good morning, Rebecca.
Hi, Ashay.
Hey.
Okay.
Just a second. You got it?
Rebecca, just a quick housekeeping question. If we're not presenting, I assume you want us to have it for sure muted, but also our video off.
I actually don't have a strong preference. I'm going to share my screen, so but definitely muted. Why does everybody have my name?
I think they're all logging with your link, and that is why it assumes that it's you every time they click on.
Right. Okay. If anyone needs to change their name, you can go to the 3 dots up at the top right corner of your video box, and there's the option to rename so I can see who you are. And we're just going to wait for a couple more minutes. We have 53 people registered today. So we will give everyone a little bit of an opportunity to join. And if you logged in with the link that I sent out and it says that your name is Rebecca Hoy, you can change your name by clicking the 3 dots in the upper right corner and going to rename so I can see who you are. All right, it's a couple minutes after 12, so we're going to go ahead and get started. We have a lot of information to cover today. So welcome everyone to Innovating the Building Envelope, presented by the Virginia Energy Efficiency Council as part of our webinar series. I'm Rebecca Hoy, I'm the Office Manager for VAEEC, and today we will explore technologies and techniques that are on the forefront of building innovation and change the way we approach energy efficient construction. I'm going to share my presentation, so give me just one moment. For those of you who, sorry. For those of you who are new to the organization, the Virginia Energy Efficiency Council, or VAEEC, is the voice of energy efficiency in Virginia. We're a broad coalition of approximately 100 members whose goal is to facilitate discussions and share resources to advance energy efficiency. Our vision is for energy efficiency to be an integral part of Virginia's economy and clean energy future. Please enter any questions you have in the chat. We'll have plenty of time during the Q&A and the discussion sessions to answer them. You can also use the chat to let me or colleagues know if you have any technical issues or other questions. Oh, it's not on the presentation. Okay. All right, one moment, please. Okay. It showed up on my other screen in presentation first, so that's wonderful. Okay. Try again. Sorry, one moment. It's not in one of our events unless I have technical issues, is it? There we go. I was sharing the wrong one. Is that better? Okay. All right, moving right along. We are honored today to have an excellent panel of experts joining us to discuss new technologies and how these innovations can scale, what the future holds for the industry. First up, we have Mike Lyon with AeroBarrier. Mike's experience in the residential energy performance space is extensive. With a building science background, his roles have included senior energy consultant with a focus on low-income government-funded housing and acting as a liaison to enable developers to meet state energy efficiency guidelines through LEED. Also, along with LEED, the Energy Star New Homes program and more. He has also worked for the prominent Center for Energy Efficiency, managing low-income housing tax credit programs in 7 states. After recognizing the pace at which builders were utilizing AeroBarrier to meet state and other energy efficiency guidelines, he decided to join AeroBarrier Corporate as its application engineer. Mike is joined by John Allen from Mid-Atlantic AeroBarrier. John is the PHIUS certified owner of Mid-Atlantic AeroBarrier, an award-winning technology that is redefining how building envelopes are being air sealed to meet any efficiency goal with a guarantee. Mid-Atlantic AeroBarrier works with many leading single and multifamily builders throughout DC, Maryland, and Northern Virginia. Next is Dr. Akshay Arora from ENCOTE. Akshay received his doctorate in structures and materials engineering from Arizona State University and has expertise in numerical modeling and simulation of thermal energy storage materials, material development, and characterization. As a research scholar, he has published over 20 publications in peer-reviewed journals and conferences in the areas of sustainable infrastructure materials. His passion for using material science to develop innovative solutions to fight climate change led him to co-found ENCODE in 2018, where he now serves as the Chief Technology Officer. He is one of the inventors of ENCODE's coding technology and has been recognized in the Forbes 30 Under 30 list for his research and entrepreneurial accomplishments. And lastly, we have Zachary Mannheimer from Alquist 3D. Zach is the founder and CEO of Alquist, a 3D printing home construction company, and CEO of Atlas Community Studios, a creative placemaking and economic development firm focused on revitalizing rural America. Zachary serves on the boards of Iowa's Public Radio and the Next Generation of Rural Leaders, and is a contributing writer for The Hill. His work has been written about in the New York Times, Time Magazine, Washington Post, Politico, The Atlantic, and dozens of community media publications. He lives in Iowa City with his wife and 3 children, holds degrees in theater and philosophy from Muhlenberg College, and harbors a self-possessed, unhealthy passion for the Philadelphia Eagles. I will serve as your moderator today and facilitator for today's discussion. So first, as I said, we have Mike Lyon from AeroBarrier, and Mike, I will turn it over to you. I have control of the slideshow, so let me know when you'd like for me to advance.
Great. Thank you, Rebecca. So today, John Allen and I are going to be co-presenting on the AeroBarrier product, the breakthrough building envelope and air sealing product for single-family, multifamily buildings. Today, I'm going to be handling the majority of the slides, and then during the Q&A process, I want to make sure we get John Allen engaged in the conversation. Feel free to go to the next slide. So when we talk about AeroBarrier, especially from the building application standpoint, whether we're presenting to for AIA credits, whether it's to local municipalities, we really want to first dive into understanding the objectives of air sealing. And first, we want to break it down into these bullet points of our benefits from reduced air leakage. When we want to look at also the financial and risk management when we're installing AeroBarrier, and also looking at air sealing reduction in general. What our current challenges are with air sealing in the building, and also for multifamily envelopes. From a manual standpoint for install and what products we're using in the space. The other thing we want to look at is the new technology, which is where we fit in. And we're going to be talking about AeroBarrier in our 3 steps to advanced air sealing. And then we'll kind of showcase real quickly our 2nd generation of the AeroBarrier line. And then we'll just do a real brief dive into some of the accolades and the certifications that we have along with the AeroBarrier product. And in the end, we won't be discussing, but we wanted to at least offer it for future reference, the case reviews that we've done with AeroBarrier. To date, we've done, outside of individual dealer case studies throughout the US, we've done DOE Building America for both new construction that was done from 2016 to 2018, roughly into 2019. And then we're currently working on a DOE Building America for existing homes that is in its completion of its 1st year, and we will still have another year left for that research. Feel free to go to the next slide. So again, when discussing the benefits of reduced air leakage, this is really important to our end user, right? So we've realized that we're reducing air leakage. We have savings in home heating and cooling. But not only that, but also reducing HVAC load requirements. So correctly sizing the HVAC equipment. And then for operational costs, because of what we've done with correctly sizing heating and cooling. We really want our end user to have a more comfortable home. And air leakage plays a huge part in that over just what type of insulation we are putting in the house. So we want it to feel warmer in the winter and cooler in the summer. Those are the goals. We want to also help prevent moisture from entering the wall system. So this is a big thing for us in terms of reducing conditions that can lead to mold growth and water infiltration. Some of the secondary benefits that we don't talk a lot about and we don't think about from reducing air leakage, but we really want to try to minimize noise transfer. And what we find is that we can get up to 40% reduction in outside noise from traffic, neighbors, and even when we say neighbors, also including the multifamily space of adiabatic wall systems. And then down specifically in the Southeast, a big point of interest, and really across the US, but in the Southeast specifically, we really can use reducing air leakage to minimize insect and pest infiltration. And so we want to seal up those gaps and create a good barrier between the outside and inside for critters to get in. And then we also want to improve indoor air quality. That we want to control air in and we want to control air out as much as we possibly can. And reducing outside air leakage is a big contributor to making sure that we're efficient with our airflow. If we go to the next slide. So we're talking about the financial and risk management. Basically, we want to look at these bullet points in terms of our area of focus. So I already kind of talked a little bit about it in the previous slide, but mechanical equipment. The first thing we want to do is we want to right size equipment and our duct systems and vents if possible. So engaging with our HVAC contractors, our builders, to making sure that this is a good first step when we're talking about air leakage reduction. So the other part of this is we want to talk about warranty. How can we affect the warranty of the space by reducing air leakage? And that should be playing into it, right? We don't want outside contaminants coming in. We don't want, again, moisture coming into the building. So that can all lead to other things that can be affecting the building products and create warranty issues. And then we also want to talk about the product build materials. So, you know, when we reduced air leakage, we're also trying to extend the life expectancy of our build products in the space. And then the other big thing in terms of what we're doing with reducing air infiltration is we can reduce it down low enough that it can have a positive effect on potential rebates, whether it's regionally based or even on a national base for tax incentives. So we talk a lot about 45L for residential and then the 179D tax incentive for commercial space. And then about the build process. If we have air infiltration issues, you know, how many trades will have to be involved in making corrections in the field? What does that do to our construction schedule, time extending out? And I've seen it go into actually delaying people moving into homes or even into multifamily buildings where you have to put them up in hotels. So there can be some really adverse financial impacts directly related to air leakage that we don't think about on the back end. Next slide. So I kind of covered this a tiny bit, a few of the previous slides, but really just diving in now to the challenges with air sealing. So with traditional air sealing, we know that we have to involve many trades. There's sometimes a phrase around you drill it, you fill it, but sometimes that gets lost in translation around who is actually filling the holes that are being drilled. And then we also need to look at the list of materials that are involved in that as well. I mean, it could range from 2 materials up to 8, sometimes 9, 10 different materials to achieve our overall air sealing goals. And then we also need to work diligently on where to seal. To be able to coach and train those in the field that are implementing, we need to first understand where our vulnerabilities are in the space. You know, if we're fortunate enough to have an architect or a developer make notations or a governing body, you know, like a low-income housing tax credit program, call out, I know specific areas or certification green in sustainable certification programs, that isn't always the case. And so we need to be able to understand where do we need to seal and who is involved in that. And so the list can be pretty extensive. And then who is supposed to be following up on that from a quality assurance perspective. And that kind of leads us into the next bullet point or topic here, which is the unpredictable results. So in my previous life, as an energy consultant, building scientist, I did a lot of testing of the building envelope space, both the duct leakage and also the building envelope itself. And for me to work with an architect or developer or a certification program where we're defining what we call our advanced air sealing details, we go through all of that work, but we don't always know it's going to come to fruition in the end. So it's kind of one of those cross your fingers and hope that we pass. And if not, you have to have a plan in place to be able to mitigate those failures going forward. And so that's why getting it right matters, what we say here at the very end. So we want to make sure that we're sealing up properly to meet code and other certification goals. And again, if we don't, what are those costs, whether it's time or money associated with that? Next slide. Oh, let's see, is that right one? Go back. Yeah, okay. So air sealing, challenges with air sealing buildings and units. We've talked about units in the multifamily. Really we need to start treating even for multifamily, those party walls, we should be treating each one of those units as almost its standalone home. It should be able to function independently of the rest, and we should be able to create an environment that can be controlled by the end user and not being dependent on the common space outside or the neighbor on the other side. So we want to be able to work on those demising walls from a design standpoint and try to minimize the air leakage through all the penetrations, not just to the exterior again, but to the adiabatic space, both to the common space and to the unit next door. And so the other thing we want to talk about is inconsistencies in the install of building materials. We can have a lack of a product, whether it be bat is cut wrong or blown in bib system, or in these examples you'll see here, we've even got spray foam where it was not put all the way, or maybe we had some delamination occur due to incorrectly during the time of year, temperature difference, or an incorrection in the mixture ratio for a two-part. And then we also have, again, the human factor. So like I just talked about before, we're designing these areas and then we're hoping that the implementation is being done correctly. So you can see in a few of these, whether you've got caulk that's not all the way to the floor and it's separated out, or it's skipping or cracked, or some area that's not being correctly air sealed. Next one. So this is a very simplified breakdown of what usually is about a 5 or 6 slides, but just due to the time constraints here, we want to really get to that Q&A standpoint. I really want to just break this down into our 3 main steps, and I'm sure we'll have questions around the aero barrier process. So I know I'm going to be leaving a few things out here, but really the aero barrier process is we are emitting an acrylic sealant into a space. So we are essentially blowing up the house like a balloon, or the building like a balloon, and we're emitting this acrylic sealant into the air, which are in small particle sizes. They are hanging in suspension, and then we're using a fan. So our generation 1 fan was a traditional Minneapolis, Florida fan. Our second generation is what we call a ruck fan that has a little bit more power. But anyway, we're pressurizing it, and we're using that airflow to move those particles around and seal up any type of leakage points in the building envelope automatically. And as long as that pressure is finding a pressure difference in the wall assembly, leading to outside the conditioned space, it will seal it automatically with the acrylic aerosolized sealant. But before we get to that point in actually spraying in the aero barrier sealant, we have to be able to prepare the space for the sealant. So the aero barrier sealant does not identify what should be sealed and what shouldn't be sealed. So in this case, we do not want to seal up any type of vents leading to the outside, whether that's mechanical ventilation or plumbing stacks. We don't want it to seal any windows, so we tape off the windows. And we don't want it to seal any tubs, so we seal off the tubs. And any sealant that is not used during the seal that is hanging in suspension will slough to the ground and settle on any horizontal surfaces in its fine particle form. So we really want to be okay with again, I should also mention taping off exhaust fans or fireplaces, or any other type of ventilation strategy leading to the outside. And any type of exterior door, we want to be able to tape that off as well if we don't have weather stripping on. So I kind of talked about that sealing process. So we're gonna take what we call a pre and a post seal. So before we even start the sealant process, we do a preliminary blower door test to understand where are we sitting. Are we at 3 ACH, 5 ACH, 10 ACH? And then what are our goals? And so we work really closely with our clients to understand what those goals are. And those goals might be driven by code performance, green or sustainable certification, or just an overall performance certification for the house that might be related to for future utility usage, and trying to minimize that. And so once we're completed with that preliminary blower door test, then that's when we strategically place our sealant stations around the space as well as part of the prep, and which we'll show a picture of that here real quick. And then we monitor everything from a software where we can see what the envelope pressure is. And once we start to emit the sealant into the air and seal the space down, we're tracking that on a graph, and which you can see in that upper right hand corner, which is actually part of our sealant certificate. And you can see on that XY coordinate there, we're watching that graph go down. And so we've got our leakage rate, and then we've also got our time. And so we're slowly watching that curve come down. And then once we've reached our desired seal, that's when we stop the pumps, the sealants, and we complete our seal. So this entire process allows us to monitor the building envelope. Again, takes out any of the guesswork of did we seal it up enough to do our final completed blower door test. And we're also being able to learn a lot from the sealant in the space. That sealant can tell us a lot about vulnerabilities in the build as well. And so we use the sealant not only to meet these goals, but we also use the sealant as a tool for learning. So we can also use the sealant data for predicting air leakage rates for different build types, depending on the makeup of the build. So there's a lot of information that we get to use with this. Next slide, please. So this is our second generation system called the AeroBarrier Connect. It is a wireless system. Everything on it is wireless except for the air that gets distributed to each one of these sealant stations with these two spray heads or spray emitters that are on top of this stand here that's on the black box. So we have what's called an air to liquid mixture. There is no chemical reaction that occurs for the sealant in the air. The sealant comes in liquid form, and it comes in a 5-gallon paint bucket, what it looks like. And it's extremely liquid and very thin. And so we have the pumps are in each one of these black boxes filled with 2 gallons of sealant. And then we have an air distribution that comes from a generator, from an air compressor outside. And when those two mixtures flow, that's when we get the correct particle size that gets emitted into the air and hangs in suspension. And then we allow the fan, this large ruck fan here, that allows it to do the rest of the work. The brains of the operation is this MCU here that is in the orange box. And that's where we monitor the pressure lines coming in, and the fan, and then the heaters. So in the wintertime, if we're in a colder climate, we have heaters that are on this fan. You can kind of see them in the opening there, that fan ring. They look like little onion rings or little pretzel shape. But there's 3 heaters in there that will also produce heat for the space. So just a couple quick things here that I know we're probably going to get to later, but we're pressurizing the envelope to 100 pascals. So that's about 25 miles an hour. Excuse me, not 25. So at 50 pascals, that's about 25 miles an hour. So we're doing it about 50 miles an hour of airflow. So a standardized blower door test is at 50 pascals. And then we're doubling that because we need to put that much force on the building in order to move the particles around from the sealant. So about 50 miles an hour, somewhere between 40 and 50 miles an hour of airflow. And then temperature wise, we need the envelope temperature to be at 40 degrees for ambient in order to spray the application inside. And then the relative humidity really needs to be at 70% or lower to start the seal because we are going to be introducing moisture into the space. And these sealant stations will shut down once they reach 90% relative humidity until the sealant in that space is being used and disperses out, allowing for the system to kick back on and resume sealing. Okay, that should be about it. Next slide. So this is just a couple of our accolades, and then some of the rigorous requirements that we're meeting in the build space. So we are Green Guard Gold certified. We are part of NGBS's certified product list. We are an ultra low VOC. And one of the biggest questions we get is, do we off gas? And through our testing, extensive testing through UL and other resources, we do not off gas. This list over here of what requirements we're meeting, that is something that we are constantly working on growing that list, which is always a question for architects and developers and other funding sources. And we do have had requests to keep adding to that list. So something usually new comes in every day. Can we meet a new requirement? Next slide. And this is just a quick breakdown of what we've identified to be, our market of interest for builders. And really, this just covers the full gamut of what is important to our builders. And so you can read this list. This is probably not going to be surprising to many of you, but we realize that the aero barrier product has a wide net of helping with different industries within the build community and different problems to solve. Next slide. I'm actually not going to get into these case studies, but I believe we're sharing the slide deck afterwards with the group, but you can just see some of the accomplishments and some of the problems that AeroBarrier has been presented with and what we've been able to do in the space. I think maybe just because we're focusing on Virginia, can we go back to the very first slide? So this is what I actually asked for our database to see what, and so I'll actually just focus on this one real quick, since this is the area that we're looking at. So almost a 9 ACH at 50 pascals was the pre-leakage test, and in an hour and a half, we were able to take the building envelope down below 1 ACH. So you can see we almost had a 90% reduction in leakage, and then based off of that, we were able to also reduce the size of the HVAC system, which is I'm seeing to be a continued benefit across the board with the product. And then this home was also, or this project was also fortunate enough to qualify for the 45L that it normally would not have if we were not able to use the AeroBarrier product, based on the air tightness results. And I think that is it, other than, again, you can look at these results and these other case studies in your own time. And if you have any questions, you can feel free to reach out. Here is our contact information. Again, I'm the applications engineer for AeroBarrier Corporate. John Allen and Michael Grove are one of the AeroBarrier dealers that are serving the Maryland, DC, and Northern Virginia area. through Mid-Atlantic Arrowberry.
Thanks, Mike.
Thanks,
Next up, we have Ashay Arora, Dr. Ashay Arora from Encode, and he's going to discuss his product.
Can you hear me?
Yes, thanks.
Okay. All right, yeah. Thanks a lot, Rebecca, and thank you everyone for being here. So yeah, today I'm going to be discussing about Encode's products and the Encode technology that we have developed using funding from the National Science Foundation. Next slide. All right, so at Encode, we are changing the world using active insulation, one wall at a time. Okay, let's go to the next slide. So what is Encode? We are an advanced materials company. We're a startup based in Phoenix, Arizona. And our focus is on developing sustainable solution for the construction industry in an effort to combat climate change. Basically, we think of us as a startup in the climate tech industry, where our goal is to decarbonize buildings and reduce emissions in an effort to combat climate change. Next slide. So Matthew and I are co-founders of Encode. We've been working a long time now, since 2013, when we were PhD students at Arizona State University. Together, we have worked on several R&D projects. Our main focus has been to scale fundamental lab scale research into commercially deployable products. And over the last years, we've worked on several of these projects in the construction industry as well as in the climate tech industry. I serve as the Chief Technology Officer and the COO at Encode, and Matt is the CEO of Encode. Next slide. So the problem that we are addressing at Encode is one that we are all familiar with: the high costs of heating and air conditioning our homes and commercial buildings. So $372 billion, that is how much we spent just in the US in 2018 alone to heat and cool our homes and commercial buildings. And with the current technology that we have, this number is projected to double in the next few years. So all in all, we've identified that there is a need for a technologically robust solution which can help us reduce these heating and cooling costs, as well as reduce our heating and cooling demands. Next slide. So, these are the current solutions. This is what people do currently to reduce their heating and cooling costs. In the construction industry, all of you must be familiar with insulation, which is, in the form of fiberglass or spray foam insulation, goes in your roofs, walls, and attics, and to a minor extent also reflective paints, where you put a coat of paint on your roof. Usually it's a white colored paint, and then it can reflect sunlight to reduce your heating and cooling costs or reduce the temperatures in your attic and so on. Now, there's a problem with these conventional solutions. Like, you can only put so much insulation in your walls. You cannot make your existing walls thicker unless it's a new construction. So there are limitations to new construction versus retrofit applications. As far as reflective paints are considered, they are usually only effective to radiant heat and not very effective to convective heat. And they can only go on the roofs that you are limited to certain colors. And so these existing solutions have that limitation. Now, with this goal in mind, and to overcome these shortcomings, we worked on developing a new technology at Encode, which we call as active insulation. Next slide. So Encode's active insulation technology has been developed using funding from the National Science Foundation. It's a patent pending technology, and it can be applied just as your normal construction paint, stucco, plaster, and wall panels. So basically what it does, the active insulation technology, is that it can transform your existing construction materials like paint, plaster, stucco, and wall panel, and impart insulative properties to these existing materials. So basically, we are redesigning these existing materials, which contractors, builders, architects are already familiar with, and adding that additional insulative property to it, which we call as our active insulation. So as a result, a very thin layer of encode paint or a very thin encode panel is equivalent to several inches of existing fiberglass insulation. So you can use that as a retrofit application as well as for new construction. So if you are going to paint your roof, you can use encode paint with it. And instead of just being a regular paint, which is used for aesthetic purposes, now it also has the additional insulator properties. Now, how does it work? So if you look at the plot below, the dashed line, that is the temperature that somebody would set their thermostat to. So above this temperature, your air conditioning would kick on. Below this temperature, your heater would kick on. In both the situations, you're actually consuming electricity to be thermally comfortable in your homes or in your commercial buildings. Now, with Encode's technology, which is a thermal storage technology, the material itself is able to capture heat and release heat at a very specific temperature. So in essence, what we see is that the gray profile is the profile of your home without Encode on it. And once you have a layer of Encode on your home or commercial building, we can identify a significant amount of temperature, of peak temperature reduction and temperature shift. Now, a combination of these two things leads to directly reducing your heating and cooling cost, as well as taking advantage of the utility time of use rates. So again, there's a double benefit of reducing your heating and cooling costs. Just like this dashed line shown, we are able to engineer our materials specific to the climate where these coatings are located. So in a hotter climate or in a colder climate, the paint, plaster, and stucco will look exactly the same, but then they are able to take advantage of the climate in those places. And as a result, you are able to see up to 30 to 40% reduction in your heating and cooling costs in both those different climates. Next slide. So as a result, as I mentioned, active insulation helps you save money on your heating and cooling costs, shifts peak load to off-peak hours, and then is able to reduce the carbon footprint of the building in terms of both the embodied carbon as well as the operational carbon. With conservative estimates, we are able to say that at scale, Encode's coating solutions can lower the carbon emissions by more than 100 million metric tons. And that is why active insulation is the green answer, where you can use it for both new construction as well as for retrofit applications. Next slide, please. So we've, over the years, we've validated and tested the technology in our lab, as well as conducted some field testing and pilots using our products. The thermal images on the top show clear distinction between Encode's paint product and a commercially available roof paint product in the market. If you look at these two images closely, you can clearly identify that the left side has a significantly higher temperature as opposed to the right side. So this was a lab study that we conducted where we took a standard wall panel and then we painted one half of it with a commercially available roof paint and the other half of it with the Encode's paint. And using thermal testing, we are subjecting both of them to the same identical heat source. And over a period of time, we are able to capture these thermal images, which are now showing what is the difference in temperature. Now, in both of these images, the difference in temperature ranges between 7 degrees Celsius to 10 degrees Celsius, which is about 10 to 15 degrees Fahrenheit difference between an existing roof paint, which is supposed to save your heating and cooling costs, and the Encode's active insulation technologies roof paint. So Further along the same line, we were able to test a product in the field to identify the effect of this technology on a larger scale. So what we did was we coated the roofs of 2 identical classrooms at Arizona State University, and we collected data on the performance of those 2 identical rooms over a period of 12 months. And we were able to measure what is the amount of airflow, or what is the amount of times that the air conditioning is kicking on. And as a result, what is the energy consumption that the air conditioning system is using. And after conducting our data analysis for 12 months, we were able to see about a 30% reduction on an annual basis between the 2 rooms. So that was another validation on a field test using Encode's paint technology. Next slide, please. So, I mean, as I initially mentioned, we are a startup. So our journey so far in our product development has been testing at different scales to validate the technology and to make sure that we are ready for commercial deployment. We started with our initial lab scale testing, where we were just able to quantify the performance of these materials on a very small scale. From there on, then we kind of developed all of these different products, paint, plaster, stucco, as well as wall panels. And then we implemented them at different scales in the field to see what is the actual impact that we can see. In 2019, we conducted our first field scale testing with our stucco product, where we basically conducted 2 identical mini houses, and we coated one of them with a stucco which is commercially available in the market, and the other one with Encode's active insulation stucco. And we had air conditioning units fit in both of these mini houses set to the same temperature, and we were able to measure how much energy is being consumed. And we saw 15% reduction in the Encode mini home as opposed to the other one. Then we conducted the roof paint study at Arizona State University, collected the data for 12 months. Beyond that, we received some funding from the Department of Energy's National Renewable Energy Laboratory, where we are collaborating with NREL to kind of conduct third-party testing on our product. And they were able to independently validate the performance and energy savings with Encode's technology. Recently, we received the funding from National Science Foundation to further improve the performance of our product and optimize it for different climates, so that we can have it work for warmer weathers as well as for colder climates. And currently, we have completed majority of our research and development, and we are now looking to partner with cities, utilities, builders, and contractors to establish commercial pilots to validate our technology further in different climates throughout the world. Next slide, please. So over these last few years, we are proud to kind of have several partners and collaborators in our journey, including the National Science Foundation, the Wells Fargo Innovation Incubator. We were also participant in the Jules Accelerator 6th cohort in 2020. And we are currently working with Duke Energy on a couple of pilot projects. And in essence, we are now looking forward to establishing more commercial pilots in different parts of the country. So yeah, if you are interested in partnering with us and helping us with our commercial deployment, helping us with our pilot projects, please don't hesitate to reach out. That is our contact information, info@encode.com. And you can visit our website, www.encode.com, and read more about us. Yeah, that's my presentation. Thanks a lot.
Thank you, Ashay. Next is Zach Manheimer with Alquist 3D. So Zach, you're up.
Great. Hi, everybody. Great presentation so far. So excited to talk about Rural America's growth plan. So MO and Rebecca, am I going to control these, or do you want to control these?
I believe you can. Let me give you remote control. Hold on.
Okay, great, thanks.
Here you go. There you are.
Okay. Okay, great. I'm Zach Manheimer. I'm the founder and CEO at Allquist 3D and Atlas Community Studios. Atlas Community Studios is a creative placemaking and economic development group. We do work in rural America in 20 different states around the country, helping small communities revitalize. We use creative placemaking and economic development tools to grow the population and the economic development in those towns. This is a map of where we've been working for the past 7 years all over the country. Average size community is about 3,000 people. We also have Allquist, the work that we're doing in all of these communities in revitalization. The number one need in nearly every rural community is housing. And that's how we fell into our work with Allquist. So Allquist sees population and housing shortages have been real for decades. The perfect storm of pandemic, climate, and economic migration is accelerating this concern. So now is the time to be bold to address these shortages nationwide. And how can we do this in an environmentally conscious way? Rural America has a housing crisis, and one solution to that is using new technology. And this is really what's driving all of the work that we're trying to do. Every time a home goes up in price of $1,000, we're pricing out 150,000 American families. So housing is incredibly out of control. Allquist 3D uses 3D printing technology to create exceptional design to lower the cost of housing and infrastructure in economically distressed and underserved communities. We have a focus on rural America because there's this myth about rural America that there's just no good paying jobs in rural America. And we know that's not true. The reality is there's thousands of great paying jobs in rural America. In many cases, we just need more people to take the jobs, but we can't get more people to take the jobs until they have literal homes to live in. It's also driven by this age-old idea of incentives for companies. We used to incentivize companies with dollars to move to our community to create as many jobs as possible. That's not necessarily a bad thing. But the problem is today, it doesn't matter how much money you offer a company to move to your town, they're only going to come if you've got a community that looks like this, that has vibrancy and is a place where that workforce wants to live. And we've been tracking new ideas for what we hope will soon be a post-COVID world. And we believe that rural America is the next place to innovate. And we're basing this on a lot of the American migration trends that we've tracked over the past 20, 30 years. What we've seen is the coasts of our country are completely oversaturated, and they have been for decades. So people are leaving and coming inward. These are great maps that illustrate that movement. Over the past 50 versus 10 years, you can see the rural population decline across the country. You can also see it here in this map showing where people went between 2000 and 2007. They largely went to second and third cities: Minneapolis, Kansas City, Nashville, Austin, Denver, Atlanta, New Orleans. Those are the cities that saw population gains identical to the population gains that a place like San Francisco saw 100 years ago per capita. Very clear. What we are in the rise right now is the rise of the third city. And that's places like Des Moines, Iowa, Boise, Idaho, Albuquerque, New Mexico, Raleigh, North Carolina, Birmingham, Alabama, Madison, Wisconsin. These are the cities that we are seeing get the population growth right now. One of the biggest ones is Richmond, Virginia. And it's not keeping track with housing production. As you can see, we dropped here completely back around the 2008, 2009 and never fully recovered. Add on to that the lumber costs are completely out of control, and they're getting a little bit better, but they're never going to get back to pre-pandemic prices, which means that right now, if you're going to build a brand new home anywhere in America, you're charging at least an average of $36,000 on top of the cost it would have cost you to build a lumber-based home prior to the pandemic. And coronavirus has caused all of this disruption, but how can we come through that? And what we're seeing now is that these migration patterns, the people leaving the first and second cities, sometimes they're completely bypassing third and fourth cities. They're going to rural communities. Now, we didn't think that that would be happening for another 10 to 15 years, but the pandemic have sped a lot of that movement up, and we're seeing these population trends come in. But again, we need places for them to live. People are fleeing big cities all the time for a variety of reasons: economic, climate, social reasons, healthcare reasons. But if they're going to come to a rural community, we base it on this rural hierarchy of needs. All of these pieces of the puzzle are needed for a community to take the next step, but the base of it is housing. And it doesn't matter if we've got great high-speed internet and medical infrastructure if there's nowhere to live. We now know that by the end of 2023, roughly 15% of every major urban area will have lost about that amount of population, about 15%. That's about 30 million Americans are on the move right now and will be through the end of 2023. So now is the time to, if you're a smaller community or any community, work to bring some of them in. And it fits really well with the major findings that just came out of this, the Harvard University study last month. Number one, the inventory of homes for sale is at historical lows. Number two, home prices are rising rapidly. We just surpassed $320,000 as the median home price. In California, it's over $1 million. Rents are down sharply for high-end apartments in some high-cost urban markets, which further illustrates people leaving urban and moving to suburban and rural. Renters and people of color fared by far the worst during the pandemic, and a growing number of people are experiencing unsheltered homelessness. These are all problems that have to get addressed, and we believe they can be addressed with using 3D technology, which can be done in an environmentally friendly way that reduces carbon load and reduces energy dependency. So this is the first ever 3D printed structure in Europe. This was printed by a company called Cobod, who's our partner. It was printed using this machine, a BOD 2.5. And we are currently working on, we've finished our print and now we're building out the rest of the home, a collaboration with Virginia Housing and Virginia Tech. The goal is to print a 1,550 square foot, 3-bed, 2-bath, single story slab on grade home and do it at the lowest cost possible. It was important to us that when we did this home, we wanted to do something that fit well with the community, that looked like a home, any other home in that neighborhood. And so we've got a very simple layout design here. Of course, we can do lots of different shapes and sizes with the printer, but we wanted to do something much more approachable. This is what the home's going to look like when it's completed later this year. A few interior shots here of the living room and of the kitchen area. And you can see here the printer in action. So that's the printer not moving at even top speeds, not even close. We've gone a little slower that day, but that's how this works. So basically it starts with a BIM model, goes into surface modeling and goes into the 3D printer software that comes with the printer called Slicer. That goes into the computer and prints the home. Pretty simple. It's actually not simple, but that works out. In terms of, especially for today's discussion, we now know that these homes are thermally broken, being surrounded by concrete. And that's going to overall reduce the energy use in these homes by at least 50%, according to the study that was just conducted by Virginia Tech of these homes. Of course, they're also incredibly strong. We know that they can withstand tornadoes and possibly hurricane. They're fire resistant and they have incredible durability. The understanding is about 175 years. We're also putting Raspberry Pi technology inside all the interior walls of our homes so we can study water, moisture issues, vibration issues. This also acts as your home alarm system and your smoke alarm system. Every home also will be coming with a personal 3D printer built into the kitchen, no different than a microwave. And we're doing this so that folks can do home repair on their own. And when we're looking at things as simple as light switch covers and things like that, we can save the homeowner lots of money on home renovations and different ideas for how we're going to play with. We also had a very unfortunate circumstance that turned into a great thing. In Richmond, we were printing, somebody broke into the site overnight. They stole our print nozzles, which is really crazy, but didn't set us back. We got out our 3D printers. We printed brand new printer nozzles, and we got back to work an hour later. This is what those look like. This is the future of extrusion coming from those print nozzles. This is a high image of the home that was completed last month. We printed the exterior walls of that home and the slab was laid a few days later. You can see right here, plumbing and electrical are in, and this week we are putting in the interior walls and roof is going on as well. This home is scheduled to be completed at the end of this year. We've gotten lots of accolades, which has been fantastic for the state of Virginia and for Richmond. And we also know we want to get into workforce development and start training programs for bring people into this work. We've got housing camp that's starting next summer to train people in this technology. And we're already starting with young folks here. These are my two kids on the site here. And you can see the differences we made between home 1 and home 2. We've recently completed home 2 in Williamsburg, Virginia. with Habitat for Humanity. The difference in the wall structures there is dramatic. There's still a very steep learning curve to this technology. There's a lot more issues that we have to contend with, but we're making pretty big strides all the time. We're also going to be partnering with One Vision Holdings, which is going to be creating a proprietary hempcrete, and that hempcrete can be used across the board for home construction and further make this a much more green home and drop our carbon load dramatically. Again, it's all about the royal hierarchy of needs that we need to pay attention to, housing at the base. And I'll show you a few images here of the home in Habitat with Habitat for Humanity. Here you can see we now 3D printed, you can see the speeds are faster. We printed that little piece of plastic there, the flap, that is smoothing out the concrete as it goes, giving the home a much better look that we like. And you can see that here in these images of the home that we have just completed in Williamsburg for Habitat for Humanity. That is, I think we're out of time, so I will skip that. But thank you, everybody. It was great presenting to you. This is my contact info here, and I will turn it back over to the host.
Thank you so much, Zach. That was really fascinating. So right now we're moving into Q&A portion of the program. We have one question that I believe, Zach, you answered through your presentation about the carbon impacts of concrete. But with the hempcrete, what's the timeline looking on that, and how will that really address the carbon impacts of building with concrete?
Sorry about that. Timeline is 6 to 12 months on the hempcrete. It's the hemp is in the ground, and it's going to be processed through our mill later this year, and we're going to be doing R&D on that most of next year. So hopefully in 2022, it'll be ready. And the carbon, it's reducing carbon across the board. Obviously, hemp eats a ton of carbon, but we think we can get pretty close to carbon neutral by doing a fully hemp, 3D hemp home.
Really fascinating. David Kaiser from the city of Alexandria is asking, are the cavities in the 3D printed house filled with anything like fill insulation?
Yes, so the ones that we're going to be doing, that we've already printed, and the ones we're going to do over the next couple of months are going to be filled with single self insulation, foam insulation. We know that that is not the most environmentally friendly. That's a big reason why we're creating the hempcrete. We also have a hemp-based insulation that's in the works as well. So I think we still have more research to do to get to the right model for insulation.
Great. So for all of our presenters, one of the questions I wanted to ask was about scaling. So I know, Asha, you said that you're working on commercial pilots. Zach, I know that you're working on a kind of a smaller scale as well. But when it comes to these technologies, how do you think that they can scale nationwide, or how can other people in other areas kind of learn from your experiences? And really anybody.
I can take that for, you know, I think scalability is the #1 issue that we're contending with right now. We've turned away about 1,000 units of housing for 2022 simply because we don't have capacity. We're scaling up we're going to have 3 or 4 printers by the end of next year, and having new teams around the country. We're planning to be in all 50 states in the next 5 years. So scalability is our #1 concern.
Mike, I'd actually like to hear your perspective, you and John, because I know that with your model, you have the corporate mothership and then the local dealers that do the actual hands-on implementation. So how does that work with you, and how do you think that is that something that you think could be applicable to the other technologies or any other technologies?
Yeah, I think the way that AeroBarrier has, and you kind of already led to that, the way that AeroBarrier, and it's the precursor to AeroBarrier was AeroSeal, and they kind of defined how they wanted to do their scalability, and they realized that they couldn't do it just by themselves, that they really wanted to have a partnership, you know, and I'm going to call it more of a franchisee model, even though it's a dealer model. that we have for it. And I think that was a very successful way for them to be able to scale up pretty quickly. And, you know, John or Michael can also talk about that as being a dealer and helping with that scalability and what that's been like to work, you know, with a corporate entity, but serving on that partnership role. But we've found it to be a very successful, and it has been so far, even on the aero barrier side, we're able to scale up pretty quickly. So in less than 5 years, we're in, I think now 40 of the 40 states, and then we're also in Canada as well. So there's 125 plus dealers now with Aero Barrier. And Aero Seal is actually international as well. And Aero Barrier also has plans to be international within the next year. So that's a big goal. But we would only be able to do that through the way that we've structured our partnerships.
Great. Ashay, do you have any insight about scale?
Yeah, well, basically, over the last 3 years, we've done a lot of customer discovery and spoken to over 400 builders, architects, and contractors, as well as raw material suppliers in different areas of the country. So based on all the feedback we received, we are currently working on a B2B model where we are like looking for builders who are like working in new construction, mostly across the Southwest, where in Arizona, California, New Mexico, Nevada, those are the states that we are targeting first. But then we expect to scale as the technology scales and like improve our manufacturing capability, because we are still at a smaller scale right now. We are only producing, like our production capacity is low at this point, but in the next coming years, after raising a couple of rounds of funding, we expect to scale to all 50 states.
Excellent. That actually ties into another question that David Kaiser has asked. Due to the phase change nature of the paint, how well does the InCoat product work in different climate zones? What climate zones has it been tested in? And does it really work when it's somewhere like Virginia, where it's very, very hot in the summer and has a pretty high humidity level, but doesn't get cold at the night like it would in the desert?
Perfect. Yeah, thanks a lot, David, for that question. Well, with our partnership with the National Renewable Energy Lab, we have been able to test the InCoat products in simulated climates between climate zones 2 and 6. So not to the very extremes, but we've tested it across those zones and identified a savings in heating and cooling costs between 15 and 40%. Now, the novel or the innovative nature of the technology is that we can change the chemical composition of our active insulation to ensure heat transfer at a very specific temperature set point. So just think of it like, as far as thermal storage is considered, just think of it like ice. So you keep your drinks inside a cooler with ice, and even when the ice is melting, your drinks stay at at 32 degrees. That's what these coatings are doing. And with the added benefit that we can tailor the composition, or we can tailor that 32-degree melting point of ice to any temperature that we want. So that is why I mentioned that it's a climate specific design. So a paint in Virginia will be different than a paint in Phoenix, but they will both be optimized so that you get the most benefit in terms of your heating and cooling costs. So we are currently working in colder climates as well. We have partnered with one engineering firm in Montana, and we are also working with another firm in New York City to kind of identify the exact performance of our products in the colder regions as well.
Great, thank you. So another question I have is, what is one lesson you learned in development or implementation of your technologies that some of the members and others that are present could take advantage of as they begin their own projects?
I can talk about it a little bit. because we've met with a lot of builders, architects, contractors to identify the product market fit of a newer technology like this. And what we have discovered, and not to everyone's surprise, that the building energy is very conservative and they need a lot of proof. They need a lot of validation and testing and results of your product. And that is why I've been focused on doing a lot of pilot scale projects and demonstrating our technology to builders and architects. One of the key things that we realized is that the industry is definitely moving, although slowly, towards materials which are carbon neutral, towards materials which can reduce the carbon emissions, towards materials which are sustainable and which have a longer life. And that has been one of the goals for us while developing this active insulation technology from the get-go, that we want to make sure that we can quantify what is the carbon emission reduction, because in Europe, let's say they have a carbon tax. In the US, we don't. It's quite possible that we might see something like that in the near future, where then builders, contractors are forced to kind of go to novel solutions. And the other thing that we've discovered is that some states are more progressive in terms of having their goals to reach net zero. And one of the reasons why we are targeting California is the net zero mandate that California has passed, where every new home that will be constructed has to meet certain net zero energy standards.
Thank you. Mike or Zach, any chime in?
A big learning curve for us is time and cost for getting this down. We know that this is going to be able to make homes significantly more affordable versus stick built. Probably need another 6 months of testing to get there in terms of speeds. But the big thing is that we already know there's a major savings cost in terms of utility bills.
Excellent. That's what we like to hear. Mike? Or John?
Yeah, I got some 2 cents. Yeah.
Oh, yeah. Go ahead. Go, John.
The biggest thing for me is to think about the actual hardware and field conditions in order to make the scalability. You know, proof of concept in laboratories is one thing, but it has to be a robust delivery system in order for it to truly be scalable, and then have a workforce that doesn't have to really do a ton of maintenance and a ton of other stuff that you know, in a chain of pieces that need to happen. If one thing breaks, the whole system shuts down. So make sure that as things are scaling, that the equipment has almost military grade robustness, because we're talking about construction sites here, not laboratories where things are under control.
That's a really good point. Ashay, David wanted to ask you, what is the flame spread of the end coat? Is it similar to regular paint, or do the components of the phase change materials increase flammability?
Well, we have kind of engineered these coatings to be in a very highly contained system. So even though there have been in the literature, some reviews point out to the increased flammability with phase change materials, our coatings and panels and the stucco and plaster have similar or better flammability constraints as compared to existing products in the market.
Great, that's good to hear. The last question that I have for you is something that we encounter a lot as we're moving into talking about energy efficiency technologies, is that there's all kinds of things out there. You know, you've got smart home technology, you have building automation systems, lighting systems, and the adoption rate is really low. What do you think some of the barriers are for market adoption, and how do you successfully or plan to overcome those?
You know, I think a lot of it is a marketing issue. Some of it's availability for sure. Some of it's that the technologies are not at the levels they need to be at just yet. But really, it's a marketing issue. I think with the folks at NCAT focusing on California because they passed those standards is a really smart move. I wish other states would do that, but we need to be out there more talking about this, getting more eyeballs on these ideas and normalizing the process, because these are the changes we have to make.
I mean, I want to talk about the same thing. What we've realized after talking to a lot of executives in the industry, a lot of architects and contractors, is that there is a big knowledge gap which needs to be bridged. So we need to have more architects, contractors, builders who are actually going to use the product into conferences, into, like events like this, where they can hear about these products, they can understand how the technology works, and then show it to them actually by like working alongside them, that this technology is easy to work with. And along with that, definitely incentives from state governments, city governments, and the federal governments do help, which can push people to, switch to other alternatives or to look for better energy efficient products.
Great. Mike or John?
My opinion is risk mitigation, and particularly in this industry that we're talking about, nobody wants to be the guinea pig. Nobody wants to own something that might fail later down the road. So, it has to be a starting small, a lot of lunch and learns, a lot of bringing in people to show that you can perform on a schedule and various site conditions, so that they can make it an easy to plug and play alternate for other things that they have going on into their flow of work, and not something that delays schedules or causes callbacks later down the road. It's really about proving that there's no added risk for what we're doing.
That makes a lot of sense, especially in light of Ashay's mentioned that the industry tends to be a little conservative and risk averse.
Yeah.
So that is all of the questions that I have. If anyone else has questions for our panelists, put them in the chat. But otherwise, thank you, all of you, so much. Zach had to jump off, but Mike, John, and Ashay, I really appreciate your insight. This was a really insightful presentation, and I look forward to seeing your successes. For all of you in attendance, if you have additional questions for the panelists or something comes up in your mind later on, you can email me or any of our panelists. I will send out their contact information along with the recording and our presentation following this event. I do want to plug that our 2021 Energy Efficiency Forum is coming up on November 15th and 16th, and will feature conversations about smart technology, building electrification, energy performance contracting, workforce development, and equity in energy efficiency. So there's a lot going on there, and it's going to be really great. Registration is open, is free for members, and you can get the link on our website. Again, if any additional questions, feel free to let me know. And I appreciate all of you spending the afternoon with us, and hope that this was as insightful to you as it was for me. Thanks again, guys, and have a wonderful afternoon.
Thank you, Rebecca.
Thank you, Rebecca.